Agentic AI, Agentic AI, Agentic AI. I'm sure you must be hearing this term a lot out there. There's a lot of buzz around all of these terms. Agentic AI, ADK, A2A protocol, MCP protocols, and so on and so forth. In this video, we are going to be unpacking a little bit of Agentic AI here. At its core, Agentic AI refers to AI systems that are designed to be proactive agents that can perceive their environment, make decisions, and autonomously take actions to achieve specific goals. Think of it as moving beyond AI that simply responds to prompts like a standard chatbot or image generator to AI that can, you're moving to an AI that can do things in digital environment, or maybe potentially physical environments as we go forward as well, right? So imagine hiring a human assistant. In the non-agentic AI world, you ask them to, a specific question like "What's the weather?" and they give you an answer, right? And then you ask follow-up questions explicitly. Whereas, with agentic AI, now you give them a goal like book me a flight to London, or open this Jira record for me for a particular story, or in the flight example, find a good balance of price and convenience. You provide that kind of a goal, and then as you work through the agent, you ask clarifying questions. Are there any preferred airlines? Morning time, afternoon, and the tool, the agentic AI uses a flight search tool. It analyzes results, and then eventually it gives you the options to go ahead and actually make that action happen. All of this is important because agentic AI represents a significant step towards more capable and useful AI systems. It allows for the automation of complex multi-step tasks that previously required significant human intervention and coordination. This has huge potential in areas like customer service, research, software development, system administration, personal assistance, and so on and so forth. In short, agentic AI is goal-driven AI that can perceive, reason, plan, and act using tools. I'm Jay Chanchlani. Welcome to my channel, and in the next 20-30 minutes we are going to be unpacking what agentic AI really means, and all of these buzzwords that you hear around you. We'll just try and understand what these concepts are and how everything comes together when it comes to agentic AI. If you want to make the most out of the video, on a separate screen, keep this README file from my GitHub repo open in parallel, and keep referring to this as you follow the video along. This has a lot of literature and theory that we touch upon during the video. This will just help you follow along the video really well. So what is it all about? Well, the official definition is it refers to autonomous AI systems that operate proactively, making independent decisions and execute complex tasks without continuous human intervention. Now think about it. That is a lot. That is a lot that agentic AI entails. That means these agents will be able to make like autonomous decisions. You can make multiple agents that talk to each other and get the work done. Think about the scalability and efficiency that you get from this. These guys are machines. These are not like you and me. These are not human beings. You can enable these to do a lot more than what you and me can do. All of that results in what? Better products, better user experience. Here are the 4 key characteristics of agentic AI. Number 1, autonomous decision making. So it reduces human effort by allowing AI to think, reason, and take actions automatically. Now think about it. You are used to programming if you code a lot in any language, but you're used to writing instructions step by step. You call this function with this set of arguments, get the output, and then process the output, move forward, take the next step, and so on and so forth. Well, all of that changes with what agentic AI can do. Now you're having these agents equipped with the underlying power of the LLMs, and which enables these agents to make decisions based on what's available out there and call these functions, tools as we call them, based on the user English language prompts and so on and so forth. That's what it really means by autonomous decision making. Number 2, multi-agent collaboration. So this allows different AI agents to specialize in tasks, improving accuracy and efficiency. So say agent number 1 did a Google search for you, brought the results back. Now based on the results, you get the other agents that can do various tasks. Open up a Jira ticket, or book a hotel, or book a flight, or send an email, block a calendar, and so on and so forth. So that enables a lot of multi-agent collaboration that can do a lot of things. Number 3, scalability and efficiency. Well, AI agents execute parallel tasks, reducing processing time compared to traditional workflows. You and me are human beings. We cannot multitask, right? We can do our brain can focus only on one task at a time. But these guys are not human beings. These are machines, and they can just run parallel flows and infinite. That brings in infinite capacity and capability. That's what gives you the scalability and efficiency. They can run parallel tasks. They can do a lot of processing in parallel that can do a lot of things. So the amount of scalability and efficiency from these machines is just infinite. Number 4, all of that results in what? Better products, enhanced user experience. So it delivers faster, smarter, and more personalized solutions for complex tasks. So what changes? It changes everything around how you have been doing traditional software engineering. If you're somebody who writes code day in and day out, well, you will still use the same kind of programming languages. You'll use Python, Java. You'll use object-oriented concepts. By the way, those are going to become more and more important as you implement some of these new agentic AI related protocols like the MCP, the A2A, and so on and so forth. You'll use those concepts a lot more, or at least at par with what you have been doing so far. But that changes the way you have been used to do your traditional programming. So in my view, there seems to be a significant shift in AI architecture with the announcement of these agent-to-agent protocols and the MCP by Anthropic and so on and so forth. The core idea is to move away from explicit programming, which has been the standard for about a century now. Explicit programming involves defining every instruction, like I said, every connection, every data flow, and decision points. Right? You make a function call with a set of arguments. You get the output. You take that output and do the next step, and so on and so forth. That leads to deterministic software that can only do exactly what it has been told, and that limits the capabilities a lot. That is what changes. The explicit programming that I talked about, the deterministic software, that changes with Agentic AI. Unlike traditional AI models that require step-by-step commands, Agentic AI works dynamically, making real-time decisions, collaborating with other agents, and optimizing workflows based on contextual data. To me, it feels like deja vu. You go back to your early 2000 days during the .com boom, when everybody was learning these HTTP protocols, the new things, new way how APIs can talk to each other, how the UI gets the data from the backend API endpoints using HTTP protocols. This feels like a new era of such a development cycle. Agentic AI, the MCP protocol, the A2A protocols are redefining how we did this communication between, say, two different pieces of code, if you will. That's what changes with the invent of with agentic AI. ADK is flexible. It stands for Agent Development Kit. It's a flexible and modular framework for developing and deploying AI agents. While optimized for Gemini and the Google ecosystem, ADK is model agnostic. It's deployment agnostic and is built for compatibility with other frameworks. ADK was designed to make agent development feel more like software development. It makes it easier for developers to create, deploy, and orchestrate agentic architectures that range from simple tasks to complex workflows. So that is ADK. Then what is Agentspace? I'm hearing a lot of terms, right? You are, if you are in this space and watching a lot of things out there, you're like, are ADK and Agentspace the same thing? Are they different? Well, there is a difference, right? They are absolutely, totally, two different things here. So while ADK focuses on building agents, it's a set of tools, libraries, and API developers that the API developers like you and me are used to create, define, and program the agents themselves. That's ADK. Whereas Agentspace focuses on running, hosting, and orchestrating agents. It's the environment or the platform where the agents, built using ADK or other methods. The agents operate, interact, and are managed here. So that's Agentspace. Think of it like this. While the ADK is the workshop and tools like the SDKs, libraries, code templates, debuggers for making these robots, right? Whereas Agentspace is the factory floor or operating environment. That's the place where the finished robots run, perform tasks, communicate, and are managed. The ADKs, so think about purpose, focus, and target users for both of these. So for ADK, the primary purpose is to facilitate the creation and development of AI agents, right? And the focus is on developer experience, ease of building agent capabilities, defining agent behavior and skills. And the target users are software engineers, AI engineers. Agentspace, on the other hand, the primary purpose is to provide a runtime environment for deploying, managing, and orchestrating one or more AI agents. The focus here is deployment, operations, scalability, reliability, security, managing agent interactions, and execution of these agents. The target users for Agentspace are DevOps engineers, system administrators, platform operators, and sometimes end users interacting with these deployed agents. If you are like me, you'll be like, Jay, enough of theory. Give me something more. How do I get started? How do I get my hands on it? Well, here is the agent, the ADK SDK on GitHub. And you'll be able to just use this quick start to just quickly get started. And I have a separate video as well that really enables you hands-on. So look at that one as well. But this is all the documentation that you will need to really enable yourselves. There are a lot of tutorials right here. There are a lot of examples that you will you'll be able to see. There is a lot of theory around the agents, tools, and everything that you might need for understanding and getting your hands dirty on ADK. So look at this, explore, spend some time on this for sure. So what is an agent? We have been talking so much about agent here. So what is an agent? Are we talking about these guys? Are we talking about this? No, that's not what an agent is in our context. Agent in the context of agentic AI and ADK is a self-contained execution unit designed to act autonomously to achieve specific goals. Agents can perform tasks, interact with users, utilize external tools. Keep that word in mind. You will hear a lot about that. So utilize external tools and coordinate with other agents. Refer the ADK documentation to understand everything that the agents can do. There are different kinds of agents, like this chart will explain, and these categories the documentation is going to explain. There are sequential agents, parallel agents, loop agents. There are core agent categories like LLM agents or workflow agents or custom agents, and so on and so forth. There's a lot of documentation that you can go through here, but for practical examples, again, I would suggest you start with something like the quick start here in the documentation. If you go to your get started and go to the quick start, you will be able to start, and otherwise, to make it simple, watch my videos, and you'll be able to get your hands dirty on this. So that's what agents are, and as you get your hands dirty, you'll get comfortable with how to work with agents and how to build agents. Let's try and answer what is a tool. In the context of ADK, a tool represents a specific capability provided to an AI agent, enabling it to perform actions and interact with the world beyond its core text generation and reasoning abilities. Underlining this, it enables the agent, the tools enable the agent to perform actions and interact with the world beyond its core text generation and reasoning capabilities. And tools are important. What distinguishes capable agents from basic language models is often their effective use of tools. Think about these tools as regular Python or Java functions. Say add two numbers A and B, and the function gives you a result back. Now you can extend that function to any kind of complex capability that you want to build in. Now keep in mind, remember the paradigm shift I talked about in the deterministic software. In what we have been used to do so far, we call these functions explicitly in our code. Like I write a line of code that calls this function, gets me the output. I write a line of code that processes this output and takes the next step. That changes with some of these. While you define the tools, but then the calls to these tools are not explicit. That's what the ADK or these agents do on your behalf, and that's the additional capability. That's the paradigm shift that I talked about at the start of the video. All of this will make sense if you start getting into the code, getting into writing some of these agents yourselves. Here are some of the characteristics of the tools or things that you can do with these tools. You can query databases, like there's data sitting in BigQuery, and if you're using Google Cloud, and these tools, you'll be writing tools that can query database or even generate SQLs for you. Making API requests, fetching weather data or booking systems, searching the web, or executing code snippets, or retrieving information from documents, the RAG, the retrieval augmented generation, or interacting with other software services. So those are some capabilities of tools that you will be able to use. And remember what I said before, what distinguishes capable agents from basic language models is often their effective use of tools. The tools are these capabilities that you see on the screen. What is MCP? Now, the Model Context Protocol. It's owned by Anthropic. It's a standardized open protocol developed by Anthropic that enables AI models to seamlessly interact with external data sources and tools, acting as a universal connector for AI integrations. Now, that's a loaded and complicated definition there. I'm sure you will not even understand at this point, or you will not be able to visualize really where this comes into play. But as we get hands-on in future sessions, I'm sure you will then realize and understand. And I'll show you an agent blueprint, what it looks like, and that will help you visualize where and how MCP fits in. But for now, understand that this is a new standardized. You can compare this to the HTTP protocol that I was talking about when I talked about the paradigm shift. So this is that kind of protocol that enables an agent to talk to a different MCP server, where your tool, or say that Google search example that I said, your Google search MCP server might be sitting somewhere else, and this MCP protocol enables your agents to use that tool and get the information that you need in your application. We'll leave it at that, and you will need to get into more details as you get your hands on. What is A2A, the agent to agent protocol? This is an open protocol enabling communication and interoperability between opaque agentic applications. Google is driving this open protocol initiative for the industry. This protocol helps support multi-agent communication by giving your agents a common language, irrespective of the framework. Like we called out initially, this is all model agnostic, platform agnostic. So irrespective of the framework or vendor they were built on, and this just gives that common language. With A2A, agents can show each other their capabilities and negotiate how they will interact with users via text, forms, or bidirectional audio or video, all while working, of course, securely. So A2A enables all of that communication. And always keep, as you're thinking about these capabilities, always keep that paradigm shift in mind, because these are the protocols that really make that shift happen, from moving away from deterministic software engineering to the agentic AI world of software engineering. Here are some of the core concepts of A2A protocol. Task-based communication. Every interaction between agents is treated as a task, a clear unit of work with a defined start and end. This makes communication structured and trackable. Agent discovery. Agents can automatically discover what other agents do by reading their agent.json file from a standard location. Very interesting concepts, and you'll see some of that in action. Framework agnostic interoperability. A2A works across different agent frameworks like ADK, Creo AI, LangChain, and so agents built with different tools can still work together. Multimodal messaging. A2A supports various content types through the parts system, allowing agents to exchange text, structured data, and files within a unified message format. Standardized message structure. A2A uses a clean JSON RPC style sending and receiving messages, making implementation consistent and easy to parse. Agents publish what they can do, the skills, along with the inputs they need and outputs they provide, so others know how to work with them. Each task goes through well-defined stages, like submitted, to working, to completed, or failed or cancelled. We can always track state a task is in, and all of that is really enabled by this protocol and working with ADK. Real-time updates. Long-running tasks can stream updates using server-sent events, so agents can receive progress real-time. Agents can proactively notify others about task updates and webhooks, with support for secure communication using JWT, OAuth, etc. Last but not least, agents can request or submit structured forms using Datapart, which makes handling inputs like JSON or configs easy. Try and visualize what an agent looks like. No, none of this. Now, our agents in our context do not look like this. Here is the agent blueprint. That's what an agent looks like in our world. There will be an agent name, right? Then there is an underlying model, LLM model that this agent uses. It could be Gemini, it could be OpenAI based model. Then there is an MCP client. The MCP client really uses the MCP protocol to talk to the external capabilities, talk to the tools. Remember tools? Very important concept. Remember what I said? Tools differentiate from the capable agents versus the others. And you tap into those tools and MCP servers, as we call them, using the MCP protocol that you see sitting in the center here, right? So that's what a typical agent blueprint is. The agent name, the underlying model, the MCP client, and then using the MCP protocol, it talks to the capabilities that are outside the agent. So that's what makes an entire agent within the agentic AI framework work. We haven't talked about the A2A yet. And that's what, because we are just talking about one agent here. A2A comes into play when there are more than one agents at play. That brings us to putting everything to use. Here is the conceptual architecture of a multi-agent app. This architecture depicts use of all options. Gemini and OpenAI models, both ADK as well as LangChain frameworks. In reality, all your agents in your ecosystem could just be using, say, just Gemini as the LLM and ADK as the MCP client. Just follow this conceptual architecture. Basically, this is depicting that there are like two agents. There is a host agent that your UI layer talks to, and that host agent really interacts with the other agents in the ecosystem. Say your agent 1 is a Google search agent using Gemini 2.5 Pro LLM under the hood, and it uses an MCP client to call the Google search API to return the results of your Google search. And there is another agent that performs another action, and that agent 2 is using, say, OpenAPI GPT 4.0 as the underlying LLM. It uses ADK, and it uses the MCP client to tap into another email MCP server that enables the emailing capabilities. So say your agent 2 has the capability to email these results that you want to. So host agent will be orchestrating and responding to the user prompts from your UI app. Will use agent 1 to get the Google search results that you want, and it will be using agent 2 capabilities to send those results or whatever you want to or email your results. That's the conceptual architecture, and you can extend this architecture to like tens of hundreds of agents out there really doing or building the applications that you are wanting to build out there. Well, that brings us to the end of this this video on Agentic AI. We looked at conceptual architecture for building Agentic AI frameworks, emphasizing agents that can act autonomously to achieve goals. We delved into the necessary components, the ADK for construction, the tools like the MCP server interface for environmental interaction, and agent-to-agent protocols for communication. Understanding all these elements is key to developing robust agentic systems capable of complex automation. I hope you liked the content, and if you did, please hit the like button for the video and subscribe to the channel for all the new upcoming videos on various kinds of technologies here. Until then, goodbye. Thank you so much for being here, and all the best for everything ahead. Thank you so much.